Happy birthday!
Happy birthday from Mrs. Lehman and her third period class. We wanted to wish somebody a very happy birthday, either a little early or a little belated. But either way, happy birthday to someone out there. All right, so anyway, today we're going to continue our work with the coordinate plane, and this is a bell ringer. Ignore the fact that it says exit slip. All right? I just tried to be extra ironic and give you that for a bell ringer. Okay, it says the first number in a coordinate pair tells you how many units to move along the y-axis, x-axis, or the z-axis. Now there's one answer that would probably get you slowly lowered out of some math teacher's windows. Now, does anyone know what answer we can immediately eliminate? Ava?
Z-axis.
Yeah, we don't know what that is. All right, so we have it narrowed down to the y and x axis, and the correct answer here, I want you to use a little sign language. Here's A, here's B. Tell me which one you picked, and I will let our viewers know. A resounding answer of B was heard around the classroom. All right, very good. So choice B is our x coordinate. That's going to tell you how many right or left to move. Can you please put that ruler down? Thanks. All right, so the second question here, it says a point on a coordinate grid is 3 units up from and 4 units to the left of the origin. So you got to go 3 units up and then 4 units left. That's going to put your point right here. What is the point coordinate pair? So coordinate pairs are always listed in what format? What coordinate comes first? Kaylin. Very good. And second is y. Now they told you this kind of in reverse order, so it's going to, kids who aren't paying attention are going to get something like this wrong. So we've got to give our location as far as the x coordinate goes first. So that would be a what? -4. Good job, Sophia. And what would be my y coordinate? Everyone?
3.
Very good. Raise your hand if you had -4, 3. Woohoo! Pat yourselves on the back. Nice job. All right. Mark this location on the map as point R. All right. Who here is feeling pretty good about this so far? Pretty easy. All right. Okay. So mark this location on the map as point R. We did that. And again, remember, a point is located where the dot is, not where the label is around it, okay? All right, so let's quickly pick one of these for checking our understanding. Do you want help? Do you need more practice? Are you almost there with this skill, or you got it? This is pretty easy. What do you guys think? Who here wanted help? Who here needs practice? Who here says almost there? And who says got it? All right, very good. So it looks like we're on in these 2 boxes, so you'll definitely get more practice here. All right, the next one is kind of turning this into a real life sort of example. It's talking about an archaeologist surveying a dig site, and they are starting at coordinates -3, -2. Mark her starting point on the map and label it S. So you got to go to the left 3, down 2. That's going to put you right there. Raise your hand if you had your point in that location. All right, if you don't, fix it. All right, she moves 3 units south and 5 units east to reach another dig location. Mark this location on the map as point T. So again, you need to know your compass rose here for this. And I always remember it because it spells we, all right? So, yeah, I mean, you've got the never eat shredded wheat kind of thing, but you never know which direction to go in. So I just always learn to remember it spells we. In case you're struggling with that. North and south are super easy to remember. All right, anyway, so 3 units south is going to put her initially right, she's going to go right there, right? And then she needs to go 5 units east. Now, I'm not going to actually have those lines on my paper. I'm just showing you that. Okay, so So that is point T. Okay, what are the coordinates for point T? Again, we got to list our x coordinate first. Sophia, 2 is our x coordinate. What's our y coordinate? -5. Very good. Who here had 2, -5? All right, nice job. Who here hadn't gotten to that one yet? All right, I don't know what you get. What the rest of you all do? You started from 0. Okay. Yep. All right, so you needed to start from math, so that was just reading carefully. All right. All right, it says if each unit on the grid represents 25 feet, so that means this is 25 feet, another 25 feet, another 25 feet, right? She's got to go all the way from here to there. How far did the archaeologist travel from point S to point T as described in 2A? So if she travels this path right here, what's the distance she's traveling in feet? Everyone's counting right now. You're counting by 25. Peyton, what you got?
She moved 75 feet south and 125 feet east.
For a total of?
200 feet.
Very good. 200 feet total. Very good. Who here had 200 feet total? Nice job. Peyton just broke that up into, you know, how many south and how many east, but together, 200 feet. All right. Who wants help, needs practice, almost there? Got it. Raise your hand if you want help on this. Who here needs more practice? Who here is almost there? And who here has got it? All right, again, we're right here. So we will practice. All right, so today what we're going to work on is working on the coordinate plane when we have points that we cannot use a scale of 1 for. All right, so most of the coordinate planes that we've looked at, including this one, the one you have on your homework tonight, is simply counting each jump as 1. But as you know, we've worked on number lines before. We can have number lines that aren't counting by ones. We can count by bigger numbers, or we could count by smaller numbers depending on our needs, okay? And the other thing we need to think about is that the x and y axis, each axis is independent of the other, meaning the x-axis can do what it wants, and the y-axis can use a completely different scale if we need it to. So we could be counting by 1s on the x-axis and maybe by 10s on the y-axis. We could alter it depending on our points. So one kind of analogy I use is if you were to move into a new room, right, you wouldn't put all of your stuff in one corner of your room and have the rest of your room empty, right? You'd want to spread it out. Same with your points. You want to make sure you can kind of see them all and you're not jamming them all into a tiny little space because you didn't use a scale that worked for those points, all right? Our goal is to utilize this space well, take into account where these points are going to fall. So we're going to look at, you know, maybe factors of those numbers, like are they all multiples of 5? Maybe we should consider something that's going to, you know, use 5s. Or I don't know. You have to look at the points and kind of look at what makes sense. But remember, x and y can be different. So let's take a look. This is lesson 17. Let me get there. Drawing the coordinate plane and points on the plane. So these guys are really great about already getting all of their x and y axes labeled and drawn on their papers because New York State was very lovely and did not do that for them. So the first one is just plotting points, all right, and they're using a scale of 1, pretty easy, straightforward stuff. So we're actually going to skip to the more difficult one on the next page, okay? So we'll come back to that if we have time. So we're going to look at example 2 for now. All right, so it says draw a coordinate plane on the grid below and locate and label the following points. So they give us the coordinates. They didn't name these points, but if we name them, we can label them with their name. Not Joe and Bob and things like that, but like just a capital letter. And we're going to then just put the point with the label next to it instead of having to write all the coordinates. Anywho, I think I'm hilarious. Nobody else is really laughing. Oh, if you can't entertain yourself, what else do you have? All right, so everyone has arrows on there. Right there, you should have arrows, so check your papers. All right, and this is the y-axis, which is our vertical axis, and our x-axis is horizontal. All right, so let's take a look at this. All right, so we want to look at our x and y coordinates separately. So for x coordinates, we have -4, -3, 1, 6, and 9. All right, and there's a saying. I'm going to use a little improper grammar here. If it ain't broke, don't fix it, right? So if you can count by ones, right? If there's nothing like crazy there, just do what works, right? So could we count by ones here? No. We have a -4, a -3, a 1, a 6, and a 9. What would you count by, do you think? Ava's saying 1. You're saying 1. Peyton's saying 1. Amaya's saying 1. All right. I would agree with you guys. You can count by ones, right? You want to kind of look for your highest absolute value, meaning, you know, what are you going to have to get to as the highest amount? And in this case, 9 would be the furthest from 0. So to get to 9, you know, we have 10 spots, so we could count by ones, no problem. All right. So, one thing that we need to do, especially now that we're altering labels or altering our scale, is to make sure we're labeling our x and y axes appropriately. All right, so this is 0, all right? And remember, we're counting jumps, so we start with 0. And then now we could go through and label each one, right? But that's going to take a lot of time and kind of make this look a little messy. So my recommendation is either counting and labeling every other or maybe every 5th one. So if we labeled every other, we would look like this. Okay, so that's one way. You could pick every 5th maybe. All right. One thing I want to ask you guys, now that we have this labeled, what is the scale of our x-axis? All right, so what is the scale? What is each jump worth? Tori, 1. Very good. A lot of kids would be tempted to say, oh, 2, right? Because that's what we're labeling. We're labeling every other, but each jump is still worth 1. All right, so make sure you recognize the difference between the scale and the label here. All right, so that's easy enough for that one. Now let's look at our y coordinates. I'm going to underline these in green. All right, so we're looking at 20, 35, -35, 10, and -40. Which of those numbers has the highest absolute value? Kaylin?
40.
Well, -40 has an absolute value of 40, right? So yeah, we've got to spread this out a little bit. So if we counted by ones, we would need a few extra sheets of paper here, right? And we don't want to do that. We can just change our scale. So instead of counting by ones, we have a few options. What are some ideas? Let's brainstorm. What do you think, Ava?
5.
You want to count by 5s. Who agrees with Ava? 5s would be a good scale. I would agree. Now, last period, a kid said, let's count by 4s, because if you counted by 4s, you'd end up exactly at 40 here, and that's as high as you would and low as you would need to go, right? The issue with that is, yeah, you kind of want to land right on a line if possible, right? So counting by 5s is going to be so much cleaner than counting by 4s. So you kind of just have to take into account what you're working with. That's going to use most of the space. So again, we don't have to label every jump. My other recommendation is that you label these on the left-hand side so that it doesn't look like negative signs on if we label on the right. I'll give you a quick example. So if we're counting by 5s and I label this one 10, doesn't that look kind of like a negative 10?
Yeah.
So if we do that on the left, it kind of eliminates that. So this would be 10, 20, 30, 40, and 50. And then we'll do the same thing down here. It's probably easier to see in blue. So negative 10, negative 20, negative 30, negative 40, and negative 50. All right, so we've got our sale, we've got our sale set up. What do you want to buy? We've got our scale set up. We've got our X and Y axes all labeled, good to go. So that's really where the work of these problems is, because it's all in the setup. All right, so now we've got these different points that we chose to call A, B, C, D, and E. We're going to go ahead and label them, or locate and label them. So negative 4, positive 20 would be right there, and that would be point A. Point B, negative 3, positive 35. All right, I'm going to pause the video while the kids work on this, and we'll come back in a minute. All right, guys, you should have those all labeled by now. Who can tell me what point or points are in quadrant 2? Amaya. A and B. Everyone check yours to see if it looks similar. All right, what points are in quadrant 4? Campbell. Very good. C and E. This is quadrant 4 in the lower right. Points in quadrant 1. Stone. Very good. Points in quadrant 3. None. All right, none of the above. All right, nice job. All right, this is actually a lesson that takes a little longer than anticipated, so we're going to continue this tomorrow. I'd like to thank you for watching. Again, I hope you've enjoyed your birthday, whenever that was. And have a great day. Keep warm out there.
Bye.
Bye.